Dear students, today let us start a new chapter, Force and Laws of Motion. Yes, dear students, in the previous chapter, that is motion, we described the motion of an object along a straight line in terms of its position, velocity and acceleration. And also we had studied motion of an object which can be uniform motion and also or a non-uniform motion. But we did not discuss about what causes the motion. Only we studied about its position and some terms related to it. So what causes the motion? Why does the speed of an object change with time? Whether all motion require a cause? Yes. If so, what is the nature of this cause? So, in this chapter, we shall study all this concept. Okay. So, what is the cause of motion? First, let us understand it. So, we have studied about a motion, but we don't know what causes the motion, is it? So, for that, let us consider a ball which is at rest. Yes, you know that in our everyday life we observe that some effort is required to put a stationary object into motion or to stop a moving object. So we ordinarily experience this as a muscular effort. Yes, and we say that a push or hit or pull on an object changes its state of motion. So here you can see a ball which is stationary, that means which is at rest. So now we want this ball to move. So here what we do? We are going to apply a force. So I am going to just push this ball. So when I push this ball, what happens? Here the ball starts moving. So then what is the cause of motion here? That is the force applied by me, is it? So this causes the ball to move, right? That means external force is needed to make a stationary body move, is it? So in the same way, this moving ball is made to stop by applying a force. You can see the ball has moved the distance to some distance, and if you want to stop it, we have to apply a force opposite to the direction of the motion of an object, is it? So that means here also the external force is needed to stop a moving body. That means here for motion and also to stop a moving object, here push is in the form of, that is the external force is applied, is it? So now here the concept of force is based on this push, hit or a pull, is it? So then what is force then? Here we understood that for the cause of motion, what causes motion? That is the force. Force which causes motion of an object, is it? We have studied different kinds of force. We have studied contact force and non-contact force in your 8th standard classes, right? So contact force we had studied about non-contact force we had studied about magnetic force, electrostatic force we had studied, and also we had studied about gravitational force. In the same way we have studied contact force, that is we have studied about the force which is applied, muscular force is a contact force. Frictional force we had studied, which is a contact force. So these are the kinds of force which we had studied, all these forces which caused a motion. So for the motion to take place in an object, that means the force is applied, is it? So now what is force then? We can define it as push or a pull acting on a body, is it? So, push or pull acting on a body is known as force. So, it can only be explained by describing what happens when a force is applied to an object. We can describe force clearly by explaining that what happens when a force is applied on an object. Pushing, hitting and pulling of an object are always all ways of bringing objects in motion, is it? So they move because we make a force act on them, is it? So here you can see some of the examples. Here the trolley moves along the direction we push it. So a boy is pushing, is it? The trolley. So the trolley moves in this direction. In the same way, the drawer is pulled. That means we are applying a force. So in that direction, the drawer is opening, is it? You can see the arrow mark. In the same way, here you can see the hockey stick hits the ball, is it? Forward. So we are applying a force on a hockey stick and applies a force on a ball. So the ball starts moving. So what causes motion here? In all these cases, the force which causes motion. So now, what are the effects? We have not seen the force, is it? We have not tasted or felt a force. However, we always see or feel the effects of force. So what are the effects of force then? Yes, force can move a body at rest. Yes, a ball which is stationary is made to move by applying a force. That means force can move a body at rest. In the same way, force can stop a moving body. Yeah, so it may be an external force applied, that is by applying a force, muscular force, or if you consider a ball which is moving on a ground, it moves for some distance and it stops after some time. For what is the reason for stopping that moving ball? That is because of the frictional force acting opposite to the direction of motion of the ball. So that frictional force which makes that ball to stop. So there also the force is required to stop a moving body, is it? So this is the second effect of force. And also force can change the speed of a moving body. Yes. How can it be done? When the body is moving, if we apply a force on that moving body, what happens? It changes its speed. So the speed of an object increases. In the same way, we can decrease the speed also, is it? And also force can change the direction of a moving body. So if the force is applied on a moving body, the direction of the motion of the object can be changed. For example, while playing football, when the force is applied, in that direction the ball is going to move. That means force which changes the direction of a moving body. Okay. And also force can change the shape and size of a body. So these are all the effects of force. You can see here a body where the force is applied on a spring, so where it changes its size. In the same way, you can see a ball, rubber ball, when the force is applied on the rubber ball, so what happens? It changes its shape and size. So these are all the effects of force on an object, where we can feel this effect of force. We can see, is it? See, we can see the changes on an object when the force is applied. Okay. So these are the effects of force. Then we are going to study now about two types of force, that is balanced force and an unbalanced force. So let us understand one by one what is balanced force and unbalanced force. As the name only suggests that balanced means balancing. Okay, let us see what is this balanced force. So before studying that, let us see here one example. I'll consider a surface on which there is one object. Consider a wooden block. Okay, wooden box is kept on a surface. Now I am going to apply a force of 50 Newton. Here you can see 50 is the magnitude of force and Newton is the unit of force. Okay, where force is 50 Newton, that means magnitude of force is 50. Newton is the unit of force. So if a force is applied in this direction, you can see the direction of the force in this way. How much force is applied? 50 Newton. So what happens? Whether the this object is going to move? Yes. In which direction it moves? It moves in this direction. You can see. So the object is going to move in this direction because the force is applied, that is 50 Newton. In this direction, the body starts moving. The body just displaces, is it? So it moves in this direction. In the same way, if we consider a surface and a box, okay, and let us apply a force of 50 Newton in this direction. Consider the opposite force in the opposite direction. The force of 50 Newton is applied. See here, in this way the force applied is 50 Newton. In the opposite direction also same magnitude of force is applied. In both the cases the magnitude of force is same, which is applied opposite to in opposite directions. So what happens now? Here two forces cancel each other. What is the net force here? So here the net force is 0 because 50 Newton minus 50 Newton. What happens? It is 0 Newton. So the net force, resultant force is 0 Newton on this box. That means in which direction the box is going to move? Whether the box is going to move? No. The box remains at rest because here the force which is applied in opposite direction, which is of equal magnitude, so the body is not going to move. It remains at rest. So this force is called as balanced force. So the resultant force is the balanced force, which is 0 Newton, is it? So we call this force as balanced force. Here it is going to be balanced. That means here the force is acting in opposite direction, which is of equal magnitude. So we call this force as balanced force. So what is balanced force? We can define it as when two forces of equal magnitude but acting in opposite directions on an object at the same time, that is simultaneously, then the object continues in its state of rest or of uniform motion in a straight line. Such force acting on an object are known as balanced force. Yes? What is balanced force? Two forces of equal magnitude but acting in opposite direction. So when this happens, the object continues in the state of its rest. Okay. So or if it is moving uniform motion, if the balanced force is applied, then it will be in uniform motion. So such forces acting on an object are known as balanced force. You can see here the girl, here one boy is pulling a rope where both the forces are equal, so there is no movement, so it is at rest. So here it is balanced force we call. So where balanced force, there is no acceleration. That means if it remains, the body at rest remains at rest, the body which is in uniform motion continues to uniform velocity. It is not going to change its velocity. So there is no acceleration. If the force is balanced, when the object is moving in uniform motion, what happens? The velocity remains unchanged. So if there is no change in velocity, that means there is no acceleration. If the body is at rest, it remains at rest, is it? So when the balanced force is applied, there is no acceleration. Okay. So you can see in the example here, a box, two forces applied in opposite direction, which is of magnitude, same magnitude. So the object is at rest. Here also, the elephant which is applying a force on opposite direction, the object remains at rest. Here you can see the force applied is 200 Newton, and here also the force applied is 200 Newton, which is opposite in direction. So what happens? The net force is 0. So we say that the force is balanced. So the resultant of the force is 0 in case of balanced force. So here also you can see the force is applied in opposite direction. Here also, here you can see the force and the distance are same on both sides. The seesaw is balanced. So here this side also 10 feet it is, this side also 10 feet. Here both are of 50 Newton. So the object is balanced. So you can see in the balance, spring balance also, where we use in the shops, that also equal quantity of magnitude. If you put on both the pans, the pan is going to balance, is it? So we call this as balanced force. So what are the characteristics of this balanced force? If the resultant of all the forces acting on a body is 0, the force is called as balanced force. That means total force is 0 here. Net force is 0 because all the forces acting get cancelled each other. So the resultant of the force will be 0. The forces are called as balanced force. So if a number of balanced force act on a stationary body, the body continues to remain in the stationary position. If the balanced force is acting on a rest body, it continues to be in the rest position. And if the balanced force act on a body in uniform motion, if the body is in uniform motion, if the balanced force act on it, then the body continues to be in the state of uniform motion. Okay. Though balanced force cannot produce motion in a stationary body. So balanced force will not produce motion in a stationary body, but it can change the shape and size of the body. Okay. There is no acceleration, but balanced force can change the shape and size of the body. So this is about balanced force. Next, let us study about unbalanced force. So what is unbalanced? So you can, as the name only suggests, unbalanced. So let us study that. So for that, let us consider a surface on which one box is kept and a force of 50 Newton is applied in this direction. Okay. So if like this, what happens? The box is going to move in this direction. At the same time, in opposite direction, the force is applied. That force is of 10 Newton. So now, in which direction the box is going to move? So 50 Newton, 10 Newton. So the box is going to move in this direction because which side the magnitude of force is more? The 50 Newton is more, is it? So the box is moving in this direction. So the net force on this box is 50 minus 10, that is 40 Newton. So the box is moving at a force of 40 Newton in this direction, is it? So here what happens? Whether the resultant of force is 0 here? No. So we say that the box is moving in this direction with a force of 40 Newton. 50 minus 10, which is 40 Newton. The body moves in this direction with a force of 40 Newton. Is it? So this is in case of unbalanced force. So here the body is, the force is acting in opposite direction, but here the magnitude of force is not the same. So the box, on the box, the unbalanced force is applied, which makes the body to move. Let us consider another example, a box which is at rest. If let the force of 5 Newton be applied in this direction, you can see the arrow mark. In the same way, opposite direction, force of 50 Newton is applied. Now you can say in which direction the box is going to move. The box is going to move in this direction because here the force is 50 Newton. So magnitude of force is more in this direction. So the box is going to move in this direction because, so what is the magnitude of force? Net result of the force on this box is 50 minus 5, that is 45 Newton. So the box moves in this direction with a force of 45 Newton. Okay. So this is unbalanced force, is it? So unbalanced force makes a body to move. So what is unbalanced force? When two forces of unequal magnitude acts in opposite direction on an object simultaneously, then the object in the direction of larger force. The object moves in the direction of a larger force. So this force acting on the object is known as unbalanced force. Okay. So in which direction the body is going to move when the unbalanced force is applied? The object moves along the direction of the bigger force. So when two forces of unequal magnitudes acting in opposite direction on an object simultaneously, then the object is in the direction of larger force. Okay. So this is unbalanced force. You can see here a vehicle, bigger force of 100 Newton is applied in this direction. Opposite to that, smaller force, that is 60 Newton, is applied. The object is going to move in the bigger force direction, is it? So objects move forward because backward it is applied 100 Newton. So 100 minus 60, which is equal to 40 Newton. So this vehicle is moving with a force of 40 Newton. So this is about unbalanced force. So you can see the examples here. So here the force is having higher magnitude. So the seesaw, you can see it is not balanced. So here you can see it is here in this side the tug of war. Here the force applied is 10 Newton. In this direction the force applied is 12 Newton. So the this rope is going to move in this direction where the force is more. So magnitude of force is 12 Newton. So it moves along Daniel and Maria. So they are the winners. So here also you can see 200 Newton, 250 Newton. So the box trolley is going to move in this direction, right force. Is it? So a wagon moving in this direction, you can say smaller force, bigger force. 80 Newton, here it is 40 Newton. So the wagon is going to move in this direction because the magnitude of force is more. So these are all the examples for unbalanced force. So what is unbalanced force? If the resultant of all the forces acting on a body is not zero, the forces are called as unbalanced. So total net force on an object is not zero, then we call that force as unbalanced. Okay. So when an unbalanced force acts on a body, it produces motion in the body. Also, an unbalanced force can stop a moving body. Okay. So unbalanced force causes motion in a body and also it can stop a moving body. Okay. If there were no unbalanced force of friction or air resistance, a moving body would go on forever. Is it? So here when the ball is moving on the ground, there is a force of friction which is acting on that ball, which makes that ball to stop. So this is unbalanced force. That frictional force is an unbalanced force which is acting on a ball. If both were equal, then the body will be at rest. Okay. So this is about unbalanced force. So what is balanced and unbalanced force? Let us understand it once again. By this diagram, you can see balanced versus unbalanced force. Here you can see a tug of war, where here this side it is of 300 Newton and in the opposite direction it is of 300 Newton. So what happens? What is the net force? 300 minus 300, what happens? It is 0 Newton. Therefore the force is balanced. So this is a balanced force. Here you can see 400 Newton, this side it is 300 Newton. So 400 minus 300, what happens? 100 Newton. That means the net force is 100 Newton. It is not equal to 0. So it is an unbalanced force. Is it? So balanced force, the resultant of the force is 0 Newton. Then we call that force as balanced. And if the total force acting on an object is not equal to 0, then it is unbalanced force. Resultant of the force is not equal to 0, then we say it as unbalanced force. So what is the difference between balanced and unbalanced force here? So balanced force is equal in size, unbalanced force unequal in size. So balanced force magnitude which is acting, the force which is acting in opposite direction is having equal magnitude. But unbalanced force, it is not having equal magnitude. The forces are different. Magnitude of force acting in opposite direction is not equal. And the balanced force, the force is acting in opposite direction. But unbalanced force, direction varies. It may act along the same direction. The total force, one or two forces which are acting, it may be in opposite direction or it may be applied along the same direction. Two forces may be along the same direction. Okay. So this which causes unbalanced force. So do not cause change in motion. Balanced force, there is no change in motion. But unbalanced force, it causes a change in motion. Yes, balanced force, there is no change in motion. Unbalanced force, there is a change in motion. So this is about balanced and unbalanced force. Hope you have understood clearly about balanced and unbalanced force. Let us continue the next topic in the next class.